Okay, welcome back. I just wanted to quickly go over some ways of being able to use Math Toolbox to be able to pull the statistics module of math to be able to do some data analysis, which is very useful in looking at tables that we might build during an experiment or a lab to be able to calculate variability, that kind of a thing. So, if you will, please, we're going to do this is data analysis is the topic. Data analysis, and it's math as a toolbox. Math toolbox. So basically, our math toolbox, if you will, if this was our math toolbox right here, the module that we're pulling out is statistics. Okay, just to put it in context. Now let's do a little bit of definitions and then we're going to go from there. So statistics, okay, basically is a tool that allows you to see the big picture. So you need to understand what statistics does for us, and this it allows you to see the big picture. What do I mean by that? If, for example, you have a lot of numerical data, say this is numerical data, and you might have a whole bunch of points that you've gathered in your data set. And what you're trying to do is look at the numerical data and be able to make some sense out of it. So you basically end up using statistics, also abbreviated as stats. It basically shows you how to make sense of the data. Shows you how to make sense of data. So the idea is when we're looking at science, you have a lot of points that you've gathered. You want to be able to somehow be able to figure things out using statistics. So a couple of things that statistics does for us. What it does is it takes a portion, a part of it, takes a portion of numerical data, and by studying it, allows us to figuring out what that portion of the data tells us about the whole. That portion of the data tells us about the whole. So we look at a portion of it and then do analysis on it and see what it tells us about the whole. So this is the key. Tells us about the whole. That's the role. Now, in order to do statistics, we got to look at some terminology that should be familiar to you somehow, as you have come across this, I'm sure, in your math and in some of your science studies. Let's talk about variables, and it'll become obvious to you. Variables. Okay, variables. Basically, a variable is something that can vary or change. That's the definition. It's a variable. A variable is something that can vary or change. Now, we're looking for variables. It is something we're looking for. It is something we look for. There's two types of variables, and we'll get them defined here. I'll use red to just be able to highlight this. One is a qualitative variable. Qualitative variable. Qualitative variable, and basically it's not expressed in numbers. This might be something like, what ice cream do I like? Okay, that kind of thing is a qualitative, not a quantitative. The next one is quantitative. Oops. Quantitative. In other words, it allows you to count it. Quantitative variable. And this one can be expressed in numbers. With numbers. Can be expressed with numbers. We can count it. We can count it. We can get a mean. We can get standard deviation. We're going to define these in a second. Standard deviation. So just be aware of that. So we're talking about all of a sudden getting a mean, standard deviation, new terms for you, perhaps, I don't know. Okay, once you finish with this, obviously as we go through this material, you could at any time stop it and move forward as you need to. So let's talk a little bit about having those variables. We can do some things like called standard variability, and I'll show you how to do that in the back. I'm going to go ahead and see if I can do this right. Standard variability. Standard variability. It is basically measured by deviation. The standard variability is measured by deviation. It'll become clear to you as we give you some examples. So if this stuff appears to be new or kind of strange, don't worry too much about it. It's really not hard. How far has a measurement, how far is away is a measurement from the mean or average of the set? That's what that means, measured by deviation. It's just simply a way of being able to say how far away a measurement, a particular measurement, how far a particular measurement is from the mean or average of the set. Again, just hang in there for me for being able to give you an example. How far away a measurement is from the mean or average of the set. That's what standard variability will give you. Now, the formula for deviation is really simple. Formula for deviation is deviation of a sample is equal to x minus x bar. What does that mean? The x, let me use a different color, is a particular value in a data set. So it could be one of the figures. So x is a particular value in a data set. X bar is the mean of the sample. That X bar is the mean of a sample. A mean of the sample. Okay. Now that you have those data, let me explain to you what does that mean. It's not a big deal. So deviation of a sample, that's the formula. And let's give an example of a data set of student heights. So I'm going to go ahead and say, let me move it out here, example. And let's figure out a data set of student, how high they are, height. Okay, so I'm going to give you example data set. Now it could be density, it could be something else that we've gathered in earth science, but in this case, just for example's sake, to show what standard variability is, let's talk about a data set of student height. So if I have a set of 3 entries, student 1, 2, and 3, and the height in centimeters is 151, 159 centimeters, that's about 1.59 meters, and 162 centimeters. So student 3 is 162 centimeters, 2, etc. You get the idea. So it's a data set of student height. Now, in order to figure out the deviation of a particular sample, the first thing you need to do is be able to figure out what the mean is. So in this case, we're going to calculate the mean. So let me, just to make the table more formal, I'm going to try to create a little table here like this. Boom. Okay, that makes it a little bit more formal. Okay, so calculate the mean or the average for that set. So calculate the mean or average. When I'm going to calculate the mean or the average, simply, how do you get the average? It would be the addition of all the heights divided by 3. So basically, the mean or the average would be x bar is equal to 151 plus 159 centimeters plus 162 centimeters, all of it divided by 3, because there's 3 entries in our table. So x bar is equal to 157.3 centimeters. Okay, so x bar is this number right here. That's an average. Now, when we figure deviation, we're going to figure deviation against a particular data set point. So, for example, now that we have the x bar, let's do the deviation for student number 2. So, deviation, I'm not sure if you can see this. Yeah, deviation. And I'm going to say student 2 would be equal, remember our formula back here, it is the particular value of the data set minus the mean of the sample, or the average of the sample. So we simply go back here and say deviation for student 2, okay, deviation for student 2 would equal to 159. That's the value of the particular, 159, minus 157.3, which is our mean. So for that particular student, the deviation, and I'm going to abbreviate it DEV, deviation for student ST2 is equal to 1.66 for that particular student. Okay, so these are the deviation for that particular student against the data set. Okay, does that make sense? And we can calculate the other ones as well. So let me go to a new page. So we're still calculating deviation. So allow me, I'm going to go ahead and go over to the deviation for student 3. So we did student 2. So deviation for student ST3, for student 3, would equal the value on our table, which is 162 minus 157.3. I'm not true. The value should be approximately deviation for student 3, if I've done my math right, will be 4.7. That's the deviation from the mean. Again, that's an important value for that particular student. And lastly, for student 1, the deviation for ST1, student 1, would be equal to 151 minus 157.3. So please note that negatives are allowed. The deviation for ST1 would be equal to minus 6.3. Okay? So those are the variabilities against the mean. Now, having said that, let's figure where do we go from here. Okay, what we're trying to do is calculate some other areas besides the standard mean that we have done here, the standard variability, if you will. So let's talk about the formula for the mean or the average. Let me give you that and continue with our notes here. So formula for the mean or average. Formula for the mean, formula for the mean or average. Formula for the mean or average. Now, some of the terminology might be a little bit weird for you guys, but it's not a big deal. So it would be is equal to the summation. Now, this symbol might be new to you. It is actually the sum symbol, sigma, or x over n. Now, sigma means the sum of all the x's. Sum of all x's. And the n, I'm sorry, this is n, not m. The n here, the n would be total number of data points. Total number of data points. Okay, so again, the best way to illustrate this is by an example. So if you take rock density, for example, example 2, data set, which is, we're getting to the point we're going to do an analysis in our own samples. Data set is rock density. Okay, so what we're going to do is sample, and then the density in grams per cc. Now, when you do that, we'll do 6 samples, 1, 2, 3, 4, 5, 6 samples, and the corresponding densities will be 2.6, 2.7, 2.4, 2.9, 3.1, and 2.4. Okay, so you build a small data set like that. So how do we calculate the mean of that? So calculate the mean. So to calculate the mean of that data set would be x bar is equal to the summation, that's the sigma signal, of x over the number of data set points. So x bar is equal to, x bar would equal to 2.6 plus 2.7 plus 2.4 plus 2.9 plus 3.1 plus 2.4, all divided by 6 because there's 6 data points. So the bar, x bar, the mean would be 2.68. Okay, now that we've calculated that, we can look at variability in each given set point. Okay, so let's calculate the deviation of a data point, sample number 1 and number 5. We'll do 2 of them. Okay, sample number 1 and number 5, 1 and 5 against that mean. So the deviation, I'm going to go to the back. Okay, so the challenge is calculate deviation of data point sample number 1 and number 5 only. So to be able to figure the deviation, remember the formula is the deviation is DEV, deviation is equal to x minus x bar. We already figured x bar. So for sample number 1, notice one thing that you got to do as you do these, you got to just keep yourself very organized. So the deviation of S1, the sample number 1, would equal to 2.6. Remember that the 2.6 comes from our data table back here. The density is 2.6. Okay, so you do 2.6 minus 2.68, which equals minus 0.08. So that's the deviation of that sample. Sample 5, the deviation of sample 5, again the same way, being organized, DEV, S5 is equal to, in this case S5, if you remember back here, is 3.1. Sample number 5 is 3.1. So we end up doing sample number 5 would be 3.1 minus 2.68 is equal to 0.42. So that's the deviation for those. Okay, for those two samples. Okay. Well, the question is, what does it mean? What does it all mean? Large deviations, positive or negative, mean the data point is off the average of the data set. That's the meaning and implication. Okay, so you need to understand this for, okay, so what does that mean? How do we take this? It just simply, so let me write it down. What does it mean? When we calculate these numbers, you're trying to generate some sort of meaning to your data, right? So basically, large deviations positive or negative, mean that data point is off the average of the data set. So if you have something that is really very large in deviation, that means it doesn't quite follow what the average does. So be aware of it. That's important to be able to determine the validity of the data as well. Okay. So, implications. Let me just write this down. And we'll be done here shortly. Implications. Okay. Why do we do this? It means that basically an experiment measures accurately and repeatedly to reduce the difference produced by standard variability. Okay. The other thing you need to understand that a sample data point with a large standard variability is suspect. We question it. We might even doubt it. Okay? Okay. I think that's enough. I think I'll stop right there. In any case, I would appreciate it if you would process this as we're going to apply this to our future data tables we're going to build or have built already. So thank you very much. Again, this is on the Math Toolbox, the set of statistics. Thank you.